Hey there, welcome to FarmCraft. We're working on a cannon. What the? So I've given this a lot of thought. It looks like probably 2/3 or maybe even 3/4 of my comments wanted me to shine it up. The more I look at it, the more that's what I want to do too, because this is pretty rough. The other thing is, people suggested, I hadn't thought about it, but it will make it stronger to have a perfectly smooth outer barrel as opposed to all these ridges where you can have stress points. I'm going to have to turn that off anyway, so that would be a problem. The other thing is in order to drill this barrel out, I've got to put this on a steady rest. The bearing on the steady rest is going to spin around here, and it would tear up that finish. So essentially it's going to look really silly if I don't shine it up. So that's what I'm going to do. Now, a lot of different ways to attack this, but where do I start? What I'm going to do is I'm going to work on this just a little bit with a flap disc, get this relatively round so that I can put a steady rest on there. Then with a 4-jaw chuck and adjusting the steady rest, I'm going to use a dial indicator to get this thing as centered as I can get it. This riser actually was not perfectly center. I just placed it by hand. It's surprisingly off center actually, but that's fine. I'm going to leave some to work with. I will turn it down so it's concentric and then drill a center into it. That's going to allow me then to have a good hold on this thing just between here and here, and then I can polish the whole cannon. Now the trunnions, they got to be there. It would weaken the system significantly if I just made this a cylinder and then drilled the trunnions in later, but this is going to have to all be handwork, because obviously when this is turning I'm not going to be able to do anything with that. I have some work ahead of me. Wouldn't you know it, I've got a problem already. So this dimension right here is 2 1/4. I've got this steady rest, which has a circle in it of almost 4 inches. I thought that'll be fine, no problem. The only thing is these fingers won't come out any further than that. So the biggest thing I can do on this is about 1 1/8 inches. It certainly will not go around that. Let me show you why. So basically what I have here is a bolt and a collar that rotates. The collar is grabbed by this set screw to keep this in position, and that allows the pressure to be exerted through the bolt onto the finger, which is just a threaded metal sleeve. The reason that this doesn't have full capacity is these are too short. I can't get the full capacity because the finger comes all the way through. If I still had some room down here, I would be able to continue to screw this thing out all the way to there. This sleeve is pressed on. I suppose I could make a different bolt and a different sleeve to make a shorter finger, but I don't have a bearing like that. I do have some bearings, but these are much larger, so I would lose some of my capacity there. It's actually nice that this bearing would go all the way down inside, and I would have a pretty good capacity, the capacity that I thought I had on this steady rest. Come on, Grizzly, what are you doing? Yeah, all they needed to do was make this 1 inch longer. Basically, if that area right there was encased in this, I could then put the set screw in, this would be fixed in position, and it would push and pull the finger depending on which way I screwed it. I'd still be able to screw it all the way in. I mean, it goes it goes past center line. How stupid is that? What are you doing, Grizzly? So it's tempting to just say, well, why don't I cut 1 inch off the finger? Just cut 1 inch off the back of this, and that would be a great solution with one fatal flaw. The threads only go in about 1 inch, and then it gets wider. I can't cut that off and then re-tap and have this part threaded. It's already wider than the threads. The only way I could shorten these fingers would be to punch out the bearing and then cut 1 inch off, and then I'd have to remill this slot, drill a new hole, and put the bearing back in. Punch. Not sure I'm not going to destroy the bearings doing this. There it went. Bearing's still fine. So right at the end here is where I'm going to be drilling through to have the pin go through, and because the keyway now goes all the way to the end, it's very thin. So I'm going to fill the last 3/8 with weld. Alright, all we have left to do is just to reassemble now. Alright, so I failed to think that all the way through. See, the bolt now is coming and it's hitting the wheel. The bolt's end is right there. So in order to get that last little bit, I'm going to have to cut the bolt off about 1/2 inch. Alright, I shortened the bolt so I can go all the way from there about 3 3/8. So about 3/4 I think would be the size of my part in the center of that. Now I can do big stuff, now I can't do really small stuff with this. It's going to work for the cannon. I'll figure out the rest later. So I did all 3 of them, and now we're ready to go. So I looked online, and a new steady rest was $140 plus shipping, and then to just buy the fingers and the bolts was going to be like $75. Kind of a rip-off either way. This steady rest is a little lightweight for me. I think I'm just going to end up building my own, and it'll be better in the long run. Alright, so now the trick is getting this thing concentric as possible. So using a dial indicator and adjusting the jaws of the chuck, I adjust the cannon so that it runs as true as possible. I'm at 70 to 80. Oh yeah, that's way off. I need to tighten that one a lot. Alright, so I've got it kind of centered around here the whole time. And you know, it's bouncing between -90 or 90 there and then almost 90 there. But given that very, very rough surface finish, that is obviously as close as I'm going to get it. So now let's see how we are at this end. A lot of trial and error and bumping and tapping, and there's no way to get this thing perfect. I think I have it pretty close. $220 RPM. So I can put the steady rest on there now and drill this thing out. So quite frankly, I'm a little nervous about this long hole that I'm drilling wandering off center as I go down the barrel. There's not a lot I can do about it. There are specialized equipment and bits for drilling long holes, but I don't have any. So I'm just going to start out with a nice 3/8 inch. I just sharpened this on the drill doctor, so it's a good sharpen, and I'm going to start drilling. So some of you might be wondering, why am I leaving that on there? My thought is, if I need to turn it around and machine the other side, that'll make it very easy and convenient to grab. It is going to make drilling this hole more difficult because I've got another 3 inches now to drill. Now I could cut it down to just 1 inch. That would still give me enough to grab. I don't know. If it doesn't get in my way, I'm going to leave it there. If it does, I'm going to have to cut it off. I'm just not concentric. It's part of the reason why I kept this, so I can just cut that off now. And I kind of get to start over. So you can see some significant casting defects there. They should get better the lower down you get. At least that's what I'm hoping. The best way to get a concentric hole is to bore it. This is my biggest boring bar. You know, this is not a huge heavy-duty lathe. Getting a bigger boring bar is not going to help. This is going to have significant flex. I'm going to drill less than 1 inch. Then I'm going to bore it exactly to 1 inch, which is going to allow me to drill with this. That will make a dimple in the end that will be centered. Then I can drill a pilot hole with this guy that will go the length. So that's smaller than 1 inch. Because I'm going to bore after I'm done with this, being concentric isn't all that critical. I do have a pilot hole down the center, but with all this irregular casting, I don't think it's going to stay centered very well. Can you see how much that's wobbling? Like most things with this cannon, this is more challenging than I expected. I'm set up with my boring bar, and we need to bore this out to exactly 1 inch now. I can feel that finding the center down in there. My tailstock is actually almost off of the ways. Now I'm not going to have to clear chips for a while because I've got an open bore all the way, to this area here. So chips can pack up in here all they want. I just need to make sure there's not too much strain on that bit. The last thing I want to do is break that bit off in there. So let's see if we can't drill a pilot hole here. So it is really wobbling in there. I don't like that at all. I have to think about this. So I went back to the 1 inch bit, which stays in the center because of the bore I've already drilled. So I have ground a chisel point on the end of this bit. Trying to drill a 1 inch hole without a pilot hole is going to be difficult without a chisel point. This is a drill bit sharpened with just a single grind, and you can see the center of it there. There is, probably 3/16 of an inch that's flat. Trying to drill through that without a pilot hole, it's not really drilling. You're not cutting a chip in the center there. You're just grinding at the center, and that's going to be very difficult to drill with. You grind an additional steeper angle here to get into that point to take out some of the meat from that center. So that is allowing me to drill straight into this with 1 inch. Now, of course, being bronze is helping a lot. If this was steel I was drilling in, this would be much more difficult. So basically I can drill about 400 thousandths, and then I have to take the tailstock off to clear the chips. There's just no other way to do it. I've never felt like my lathe was small until this. Hey A-bomb, help a brother out. So I'm getting ½ an inch with each one, so that's not too bad. Every two I'm getting an inch. The cannon's only 21 inches long, so. The last drill, and the bore will be done. This has been the most tedious hole in my life. Boy, I could make a lot of things out of that. Work to death. So I just cleaned up all the gunmetal off of the lathe. I got 3.6 kilograms. Now some of that is mixed with grit, but the vast majority of that is metal. That's about 8 pounds. So quite a bit of metal in that bore. I may remelt that in the future. If so, the grit will float to the top. Actually have an idea of something I could do with that. That's my buddy. He keeps the mice away. So I have a little bit of a challenge here. I've got this thing running very true, and it's true when I do it sideways as well. The issue is that even though that's staying true, it is not centered right now. And the reason it's not is because this thing has some flex in it. I've got the whole thing cantilevered out, and if I push up even just a little bit, it moves. So this thing is hanging out and it's flexing down as I rotate it. So it is in the center side to side because, you know, in this direction it's also running true. So it finds the proper center that way. It does not find the proper center vertically. And it's very difficult to know where that is. I can put a steady rest underneath this, but whatever I set the steady rest to, it's just going to hold it to that new level. And it'll flex to the steady rest just like now it's flexing to gravity. So where is that center? It's kind of an interesting little problem. I could put a center in this thing right now and do it. They'd be slightly out. You'd never know, but I'm kind of curious about getting it right from a machining standpoint. I realized a solution. I can take a center, I can push into this, and then I can tap this until I get it where I want it. This bronze is slightly malleable, so the center will be pushing the bronze in the direction I want it to move that center slightly. You know, talking thousandths here. Using a live center is not the best thing because there's a bearing in there and there's a little bit of play in that. So what I'm going to do is I'm going to change this out for a dead center, and then using a dial indicator I'm going to tap, tap, tap and get this perfectly concentric. That's the best solution that I've come up with. I think that'll work. So those of you not familiar, a live center has a bearing so that the center can spin, and a dead center is just a solid piece of metal. Obviously it's not going to spin. On this, the spinning all occurs in these bearings that can take the high speed. On this, you lubricate between the center and your piece. It spins right there. Will do some damage or, you know, have some effect on the piece where they're in contact. Alright, so I've got that locked in well. So I'm 10 thousandths out. That's my high spot, so that's where it's too far this way. Tap. that is within 1/1000th. That worked quite well. Alright, so I've put it on the steady rest, and I'm actually going to take off the dead center and center drill it. Now I could put the live center in there and do the rest of the turning with a nice center in. So ultimately I'm going to round this so that it looks more like the original with kind of a ball that comes down to a neck. But I expect I'm going to be putting this back on the lathe even after I fire it. So for right now I'm just going to make this a cylinder. I'll give myself a radius in here, and I'll just kind of freehand this area in here. So I'm going to polish all this with various grits of sandpaper. What's really intimidating here is the thought of this thing coming off the lathe while I've got my hands right here. If it came off so quickly, I mean this thing weighs 50 pounds, it would just break my arm like it was nothing. So I've got a live center here, you know, that is adequate to hold it. I'm not going to trust that. I'm going to put my steady rest right here on the back and have it in place to catch if anything happens with the live center. I'm not going to really run it on the steady rest, but I just want it there in case anything were to get loose when I'm not paying attention or something. Because that would suck. This area is even rougher, so I think I'm going to start out with a file. See how that works. Here, I think you can probably see how rough that is. This is after 1,000 grit. I'm using white buffing compound. That side's polished, that side is not. More shop glitter. Yay, shop glitter. And it goes in nicely. So that's going to allow me to turn all of that on the lathe. Somebody left me a little present on my workbench. with how this thing came out. I think it looks great. Let me come clean with you. There's one problem. I want to get some experienced opinions on what they think the results of this are going to be. There is a defect inside the bore. It's about in this area here. I think what that means is I'm down to just over ½ an inch at one point out here. The breech looks good, but let me put a camera in there and I'll show you. All right, let's go all the way in. Here's the back of the bore. See, the walls look good. There, that's the one that's so that defect is right there, close to a ½ an inch wall thickness, but it's way out here. You know, the chamber pressure is all back here, and this area looks good. How much is that going to matter? Any gunsmiths out there that actually have some knowledge with this kind of thing? What kind of chamber pressure am I going to expect this far out in the barrel? So it is what it is, and hopefully it's not going to fail. We're going to find out though, I guess.